Okay, so higher order derivatives is just taking more than one derivative. So you take your derivative, that's just the first derivative. Okay, if you need a second derivative, it's just taking the derivative of the first derivative, and it's denoted by f double prime of x. Or it can be written as d dx, the derivative of f prime of x. Okay, third derivative, you take the derivative of the second derivative, and that's f triple prime of x, or the derivative of f double prime of x. Okay, and you can continue, and you can find as many derivatives as you want, okay? Yes. Okay, so here is some, like how it's denoted for those. Okay, y prime is the first derivative, y double prime is the second derivative, and so on. After we get the third derivative, we just start putting the number of the derivative up here, okay? So you don't have to put, like, 10 of them up there, yeah.
Yeah, but y to the fourth.
That's why you put the parentheses at.
Yeah, yep, so there's like parentheses around that, okay? So it's not like a y to the fourth, it's the fourth derivative. Okay, same idea for f prime, This here, remember dy dx. For the second derivative, it's d squared y dx squared, and then d cubed y dx cubed. So if you see these, just look at what number it is, and that's the derivative you're looking at, okay? Same thing here, and then here, whatever the number is what derivative you're looking at. So let's try the first example. Find the first four derivatives. So this should be pretty quick. First derivative is what? 18x squared minus what? Minus 4x. And then the second derivative? 36x minus 4. And then the third derivative? 36. And then the fourth derivative? 0. So if it asked you for the 100th derivative, would you have to do this 100 times? No, because it's going to be 0 from there on out, right? You could if you wanted to. Okay, let's try number 2 here. I'm actually going to give you guys a chance to try it before I do it, because I think you all know how to do that. So I'm going to start it up here. The first derivative, you guys get 4x cubed minus 3x squared plus 2? Cool. And then the second derivative, pull the 3 down, and I get 12x squared minus 6x. This is the fast way. Yep.
That's what I thought.
And then the third derivative, pull the 2 down, and we get 24x minus 6. And then I want the third derivative at 1. So I just plug 1 into that last one. I get 24 minus 6, which is 18. So that would be my answer there. So questions on that at all? Pretty easy, right, the idea of it? Okay, now the other side here, you might want to highlight a couple things. We're doing position, velocity, and acceleration. So when it's talking about these, you just have to make sure you do them in the correct order, okay?
Position times velocity equals acceleration.
Okay, so your position function is your original function. So position is like your y equals, okay? Your velocity is like your y prime. It's your derivative of your position. And your acceleration is y double prime. Okay, it's the second derivative. And after acceleration comes this thing called jerk. That's actually the third derivative. People tend to think that's funny. That's actually what it's called. But you won't get, you probably won't have any of those in your homework. The jerk is the derivative of acceleration. It's like when you're driving in a car and, you get that, like, yeah. Yeah, I should. The jerk is just the third derivative of the position. You don't have to know that. It just makes people laugh. So. But it really is that. Yeah, just call people the third derivative.
Third derivative.
Okay, so previously you learned that the derivative of the position function is the velocity. So s, it's often denoted with an s, the position is. So that's your position as a function of time. The derivative of that is the change in position with respect to time or velocity. And then if you took the next derivative, you'd be looking at the change in velocity, which is the acceleration. Okay, so we're given our examples here. It says a ball is thrown upward from the top of an 80-foot cliff with an initial velocity of 64. So where does 64 get plugged in? Yeah, for my what here? V naught. Okay, so plug that in for V naught here. It says give the position function, or given. Oh, give, because we need that. Yep, and then my 80 is my H naught. Good. And just plug those in to get your position function. So that's the first thing they want you to do. This H naught is always your initial height, and V naught is your initial velocity. So they give you initial velocity, and they say it's, this is the top. That's where it starts. So that's your initial height. So you have negative 16t squared plus 64t, and then plus 80. So that's the first answer they want. It says then tell the velocity and acceleration functions. So velocity function, what do I do? The derivative. So I do the derivative of my position, which gives me negative 32t plus 64. And then how do I find my acceleration function? Yeah, you take the next derivative, right? It's the derivative of velocity or the second derivative of position. You don't have to write all this out each time. It's just for your notes here. So I get negative 32. Now let's just label these just for us to have the labels. What would be the label of a position in this case? Feet, right? What would be the label for a velocity? Feet per second. Yep, and here it's actually given in like a feet per second. And then how about accelerations? Anyone know what the label for that is? Well, no, that would be a velocity. Feet per second or feet per second squared. I mean, that's what it is. So sometimes it's written like this, or sometimes it's written as feet per second per second. You'll see that if you take like a physics or something. Okay. Okay, when is the ball going to hit the ground? When what's 0? The height, right? When the feet is 0. So you set your position equal to 0. So let's start with that. So hits the ground, I'm just going to say S of t equals 0, and then I'm going to write my S of t out here. What comes out of all of those numbers? 8, even bigger? 16. So I'm going to divide everything by negative 16. So this just turns into what? T squared. Divide this by negative, and it's going to become a negative. And what's 4? And then how about this one? Minus 5.
8 divided by negative 16. Trust me, I don't think of it on the spot.
Okay, now we want to add to here and multiply to here. So it's going to have to be a 5 and a 1. And which one's positive and which one's negative?
5 is negative.
The 5's negative and the 1 is positive, right? So what are my t values? 5 and negative 1. Now, it probably doesn't make sense for it to hit negative 1 seconds, right? Because it would be before you actually even threw the ball, right? So we're going to use our t equals 5 here. And it says, what are we supposed to do with that? Velocity and acceleration. So now you use your velocity function, and we're going to plug 5 in. And then use your acceleration function and plug 5 in. I'll take care of the acceleration for you guys.
Oh, thanks.
You're welcome. Yep, that's good. And the velocity, did anyone come up with that? Negative 96. And the label is feet per second, we said. So that just means that it's traveling down at 96 feet per second, which makes sense because you threw it off of a cliff, right? I mean, you can. Yes. This, just so I could solve for my t's. Yep. You could try to just factor this to begin with, and you'd still end up with these values, or use your quadratic formula, you'd still get these values. But if it's an equation, like an equals, you can divide everything by the same value, and it's still an equivalent equation. So it's kind of like, subtracting 80 from both sides. You can do that as long as you do it to both sides. You can divide everything as long as you divide everything by it. Okay, so that's if it's an equation, you can do that. Okay, so that means the ball is falling with a velocity of 96 feet per second, and the acceleration is 32 feet per second squared when it actually hits. So, okay? And that takes care of the notes there. 2 to 44 even, yep.